Moon phase is day 7, April 3rd. Today's question at the top, learning target and key vocabulary. Lesson introduction. Previously, we have learned that the Earth's rotation makes it look like the moon is moving across the night sky. We have also been practicing with the different moon phases. Today, we will explore the moon's tilt and what is happening in space that makes a solar eclipse so rare. This is a helpful link. It shows the video of Earth's orbit. Some new vocabulary. This actually isn't new, it's a review, we already talked about it, but to remind you, waxing, we are able to see more of the moon, so the lit part of the moon appears to be getting bigger and bigger. Waning is the opposite. The lit part of the moon appears to be getting smaller and smaller, so we can see less of the moon. All right, here we have a model that shows Earth's orbit and the moon's orbit. So remember that Earth is tilted on its axis and it's orbiting around the sun 365 days a year. A plane is an imaginary flat surface on which the orbital path is completely found. So the Earth is never going to move off of this blue line that indicates its orbit. It's kind of hard to imagine because it doesn't really move on a line, but it's always going to move in this same way. However, you notice here that the moon is on a 5-degree tilt. That makes it on a different plane. So it is not moving around the sun or around the Earth the same way that the Earth is moving around the sun. It has a little bit of a different plane, and that's going to be important in a minute. So when the moon moves around the Earth, its revolution is 5 degrees tilted from the Earth's solar revolution moving around the sun. This is what it looks like. Here we have the moon, the Earth, and the sun. This X shows the two places where the orbits intersect. The moon is orbiting around the Earth on this axis. The Earth is orbiting around the sun on this axis. Because of the tilt difference on their orbit, there's only 2 times when the Earth and the moon could potentially intersect their orbits, which would lead to a solar eclipse. So how does this tilt affect the amount of light that we see from the Earth? How might this add to our theory about why we do not see an eclipse every 29.5 days? So to stamp at the bottom, the moon moves around the Earth on a different path than the Earth revolves around the sun. This means that there are only 2 spots where the paths line up and could have all 3 objects in one line. The moon does not easily line up with the Earth and the sun because they are in different planes of orbit. Sunlight can almost always reach half of the moon and half of the Earth. The exit ticket is here. It says, this model shows the revolution and rotation of objects in the sky. What do we know is true about the moon revolution that cannot be depicted from this viewpoint? A, the moon is in a moon phase, but we cannot determine the phase from the image. B, the moon revolution is on a different plane than the Earth's revolution. C, the Earth and the moon are revolving at different speeds on the same plane. So think, which of these 3 things did we talk about in this lesson that impacts why we don't have a solar eclipse every single time that the moon orbits the Earth?